This video is for topic 8.2, pH and pOH of strong acids and bases. The objective for this topic is to calculate pH and pOH based on concentrations of all species in a solution of a strong acid or a strong base. So the first thing we need to do is define what it means for something to be strong. When we talk about a strong acid or a strong base, we're not talking about how acidic or basic something is. It's not related to the pH. What it's related to is how it ionizes or dissociates in solution. So a strong acid and a strong base will completely ionize in solution. That means instead of staying in its acid or base form as a molecule, it breaks apart into its two individual ions. So if it's an acid, it's going to separate into its hydrogen, and then whatever the negatively charged part is, whether it's a single element or whether it's a polyatomic ion. If it's a base, it's going to dissociate into its hydroxide ion, and then whatever the positively charged ion is, whether it's a single element or a polyatomic ion. When we talk about strong acids and bases, we can assume that the concentration of the acid is the same as the concentration of the hydronium ion, and the concentration of the base is equal to the concentration of the hydroxide ion. So we make this assumption because we've said that they're strong, and strong means that they completely dissociate. So that tells us that our concentration of our ion is the same as the concentration of the molecule or the compound together. So this means when we go to calculate pH for an acid, it's the negative log of the hydronium ion concentration, which in this case, if the hydronium ion concentration is equal to the acid concentration, pH is simply the negative log of the concentration of the acid. We have a list of the 6 strong acids below that you will want to have memorized so that you recognize that those are the acids that are going to completely dissociate. If they are not on that list, then they are not considered a strong acid. Bases work the same way. If a base completely ionizes in solution, then the concentration of the base is also going to be the same as the concentration of the hydroxide ion. This means that pOH, while it's normally calculated by the negative log of the hydroxide ion concentration, if it's a strong base, we can calculate it by the negative log of the concentration of the base. Our common strong bases are group 1 and group 2 hydroxides. So the metals in group 1 and group 2 on the periodic table, when they're bonded to a hydroxide, they're considered strong bases.